Here are some reactions for aromatic reactions. So here's the benzene ring. So we have toluene in the first one and Br2 FeBr3. So the catalyst tells me that the reaction is actually happening on the benzene ring. So now all I have to determine is where the bromine is going to go. So if here is my methyl group is an activating group. So it means that bromine is going to be either here or it's going to be para. Okay, so either ortho or para. So you don't have to write both. It's kind of understood, or you can write plus para, okay, if you need to, but usually you can just get away with one. Now, in this case, this is new actually. We have Br2 and H new, and I wrote this question out so that we can talk about how you have to really observe your reagents. In the first one, we had bromine with FeBr3, so iron 3 bromide, that was a catalyst. On the other hand, here you have bromine with presence of light. It means that the reaction is actually happening outside the ring. So in this case, the bromine is going to actually go outside. Okay, and so not on the ring, but this is a side chain reaction and generally is going to be the vinylic position, the allylic position. So 1, 2, 3. All right, that's the allylic position. So that's where the bromine is going to go. So that's how the second one works. Let's look at reaction B. And in case of B, we have parabromotoluene. And the first reaction we have to do is with nitric acid and H2SO4. So it means that I'm doing nitration. So I'm going to write out all the products that we'll get, okay, for this one. So here is the bromine. Now both bromine and methyl groups, they are both activators. Bromine is not so much of an activator, it is an orthopara director. Methyl is an activator, so it means that the nitro group is going to go pretty much ortho, okay, to the methyl group. So that's the nitro. Then the second one is where you actually have zinc and HCl. So zinc and HCl tells me that I am doing reduction of the nitro group. So my Br is still there and now I have NH2. So I did reduction. The third one is sodium hydroxide. So the third reagent is not going to be for the nitro group. It is going to be for bromine, and so this is going to be an SN2 reaction. And remember that SN2 reactions on benzene rings are very rare, and this is one of those rare ones. Okay, so you can do SN2 substitution on bromine to give you OH because this is sodium hydroxide. So this is actually a very harsh reaction, but this is something that we can do. So this is a three-step reaction. So the final answer, of course, is going to be this, okay, of the series of reaction, but I wrote it out one by one so you can see how the process is. So make sure you also write it out all one by one so you can reach the final answer.